is to find the derivative. So we are going to find the derivative.
Could that be 6x squared?
6x squared minus 6x minus 2. Yes. What is the second step? We have to find a critical number. A critical number or a critical value is a place where the derivative is either 0 or it doesn't exist. So going to set the derivative equal to 0, 6x squared minus 6x minus 2 equals 0. What is the very first step before you start solving this?
Take out like term.
Those,
Take out like term. So
which is 2, right? I have a 2 in common. It's better to take the like terms out before we proceed. So divide by 2 on both sides. And we'd end up having 3x squared minus 3x minus 1 equals 0. Yes.
It would be best to take out that point.
Never mind. So 3x squared minus 3x minus 1 equals 0. What type of equation is this? Quadratic. And how do we solve for x? You did.
In the interval, right?
Yeah.
No, not yet.
I think what you say.
I said factor.
Factor. Of which would we be able to factor this? Not really. So what's the, we might be able to, but what is the other way?
I mean, technically, you have.
This is a quadratic equation. How do we find the roots of a quadratic equation? We use the quadratic formula.
I get mixed up.
Which I can use.
You should know how to use the quadratic formula, so tell me what the roots are. So the roots are the solution, or the solutions would be minus b minus 3 plus or minus square root of b squared, negative 3 squared, which is 9, minus 4 times 1, or negative 1 times 3, divided by 2a, so 2 times 3 is 6. So we will end up having 3 plus or minus square root of 21 divided by 6. So 3 plus square root of 21 divided by 6, and 3 minus square root of 21 divided by 6. And both of them will lie inside the interval. Yes. Square root of 21 is about 4.5. So 4.5 plus 3, 7.5. Yes, that will lie in there. Minus 1.5 divided by 6. That would also lie there. So since we have two critical values, we know exactly what the minimum and maximum are going to be. So the absolute minimum, since we have an interval, could be at an endpoint. The absolute maximum could be at an endpoint. So I'm going to plug in the endpoints first. F of minus 2. You can use tagging set if you want. Negative 16, negative 12, positive 4, plus 1, negative 23. Do the same for the other endpoint. -34 minus 27 minus 6 plus 1, 22. Good. So based on what I see, I start at a negative value and somehow I end up at a positive value at the other endpoint. So my guess, even before I graph it, something like that. That's just my guess. So go ahead and graph the original function and tell me if this matches up. If I did a good job, it was awful. Is it?
It's kind of a question on my calculator. I got a decimal. Would that be the same answer?
Yeah.
1.6?
I'm just being nerdy, that's all. Okay. So I didn't even use a calculator. I just knew this is what the picture is going to look like. How did I know? Well, a few things. First, two critical values, and I know both of them lie in this interval. And at -2, the value of the function is 23, -23. Yes? At 3, the value of the function is positive 22. So I know that, and I know that there are two critical values in the middle. In other words, there are two places where the derivative would be 0. That simply tells me that the curve did 2 turns in the middle. You can't go from a negative to a positive without 2 turns in this case because you have 2 critical values. That number is 3 minus square root of 21 over 6. And that number is 3 plus square root of 21 over 6. So approximately, what is this? -2. Not -2. -0.2 something. 0.26. And that would be 1.26. Good. So since there are 2 critical values, there are 2 places where the derivative is going to become 0. And anytime you get these numbers, it tells you that the function is making a turn at each of those points. It could either turn this way or that way, but it is making a turn. If it doesn't exist, then the function is making a sharp turn or there is a discontinuity. Good. So in this case, those are the 2 numbers. Is there a maximum or minimum at 3 minus square root of 21 over 6? Right here.
There is a maximum.
It's a maximum. Is that a local maximum or absolute maximum?
On this, or local.
Local? I don't know. It has to be local. That's a local minimum, yes, so. I don't know its value, but from the looks of it, that's going to be a local maximum. And local minimum. What is the absolute maximum, or where is the absolute maximum? The endpoint. So the absolute maximum is at 3,22. Where is the absolute minimum? Endpoint. Right here. Absolute minimum. So we set the second derivative equal to 0, solve for t, and we got 0, -2, and 2 as the critical values. One of them is an endpoint, so evaluated the function at -2, evaluated the function at 0, evaluated the function at 3, which is another endpoint. So since I see critical values -2, 0, and 2, the function's likely to turn at those places. Now you know exactly where to look instead of scrolling through that picture or going back and forth. Sorry.
So like, why didn't you put in like 2 as well?
You can, no big deal.
Okay.
Nothing wrong with it. So f of 2 will still be 0.
Oh, okay, I see.
So things to note. We had critical values, but here it's not, it did not correspond to a minimum or a maximum because it's flat. That's why we got the derivative 0. Same over there. So even though -2 and 2 are critical values, they do not correspond to a minimum or a maximum. However, the critical value 0 does correspond to a minimum. In this case, -2 gave me 0, that is one endpoint. +3 gave us 125. Another endpoint. Yes, so 0, -64, and 125. What is the absolute minimum?
0, -6.
What?
0, -6.
0 and -64. So that point is the absolute minimum. That's a coordinate. What is the absolute maximum? 3,125. Is there other local minimum or maximum in this problem? No. So key thing to note here is just because you have a critical value, it doesn't imply there has to be a minimum or a maximum. There is a theorem that comes in the next section. I'll save it until then. Are we clear?
Yeah. Lovely.
This is yet another example where the graph is not the best thing that you can go with. But if you did a bit of calculus, you'll know exactly where to look at. Then you can make whatever decision that you want to make. So most of you went with product rule, perfectly fine. I'm going to be special and use quotient rule instead.
Like quotient.
Yes.
I was just saying personally, why get you?
I like positivity.
Oh.
So we want to find the derivative. So u is ln of x, v is x squared. I just moved x raised -2 from the numerator to the denominator. Regardless of what you do, you will get the same critical value. v squared, x squared squared, v x squared times derivative of ln of x, 1 over x, minus ln of x, derivative of x squared times 2x. The x and the x would get cancelled, or x squared. We will have x minus ln of x multiplied by 2x divided by x raised 4. What do I have in common in the numerator? And x is in common. So if we take that x out, I'll have 1 minus ln of x multiplied by 2 divided by x raised 4. My brain's go one step ahead. So the final answer would be 1 minus 2 ln of x over x cubed. Those who did product rule, you can combine the terms that you have by finding the common denominator, and that is exactly what you will have.
I got 1 plus 2 on that.
What happens to the
Yep. That was my mistake.
Okay, so even if you did product rule, you can simplify algebraically, and this is the answer you will get. Now I'm going to set the derivative equal to 0, which would mean 1 minus 2 ln of x equals 0. Or divided by x cubed equals 0. For a rational expression to be equal to 0, the numerator has to be 0. So 1 minus 2 ln of x equals 0.
Meaning that we're going to have to get it to ln of x is equal to 1/2.
It doesn't-
So what happened to the x cubed when I set the derivative equal to 0?
It doesn't.
It really doesn't matter. For a rational expression to be equal to 0, all I want is the numerator to be 0. Right, so yes,
Wouldn't the answer for x be e to the power 1/2?
patience, I'm getting there.
I'm just saying.
So move negative 2 ln of x to the other side. So 1 would equal to 2 ln of x. Divide by 2 on both sides. Ln of x would be equal to 1 over 2. Let's see if you remember unit 1. What type of equation is this?
Wait, why would you ask what the, but you could literally just solve it by.
No, answer my question.
Repeat the question.
What type of equation is this?
Natural
Logarithmic equation. We solve a logarithmic equation by doing what? And now is your time.
multiplying by its base. I mean, putting it to the base of the power of, sorry.
Exponentiate.
Okay.
Exponentiate.
Exponentially, that's what I mean, sorry.
E raised ln of x is equal to e raised 1/2.
Pressure, just. I mean, hey, you know what? Life
It's
is.
okay.
Please
The
don't-
e and the ln would get cancelled.
Got it.
So x would simply be equal to square root of e. Yes, so which is simply square root of 2.7182. And what do we get? It's approximately 1.65. 1.65. Now, this particular number, you could not have seen it from the calculator. By all means, your calculator probably goes like that.
Yeah.
Yes, so now you know exactly where the term supposedly is at, 1.65. Now you can go back and see whether it is a maximum, minimum, or if it's flat. So you can use, so in our case, going to erase this part.
Which if you want to.
What, you okay?
Yeah, I'm great.
So it sort of goes like that, that would be 1. And this value, 1.65 is square root of e. And we have a critical value, but it does not correspond to a minimum or a maximum because the function becomes flat again. So to find the absolute minimum maximum, what should we use? We should simply use the endpoints. So in the problem, it was 1/2 and 4. So when I plug in 1/2, I'm going to get a negative number. Divided by 1/2 squared. 1/2 squared is simply 1/4. What rule can I use to simplify the new? You could use a calculator, but can I write ln of 1/2 as ln of 1 minus ln of 2?
Yeah.
Divided by 1/4. What is ln of 1? 0. 0 minus ln of 2 minus ln of 2 divided by 4. Excuse me, 1/4. Flip and multiply, you get -4 ln of 2. So the place where we have the minimum, absolute minimum, is at this endpoint, and the value is 1/2 comma -4 ln of 2. Where is the maximum? The maximum happens at 4. So that point would simply be ln of 4 over 4 squared, which is 16. Of course, you can use the calculator, right? But
Where's the problem?
where is the fun in that?